Hey guys, so today I want you to do an activity where you're going to gather a couple of numbers from your house or from wherever, and then make a percent comparison between those two numbers and post a video to a Flipgrid topic that I created where you'll explain what your numbers are that you have and show your work and your math on how you make a percent comparison between those two numbers. And so when I say a percent comparison, what I mean by that is if you have two numbers like 15 and 10, you could compare them by saying, well, 15 is 50% bigger than 10, or 10 is 33.3 repeating percent smaller than 15. So when you say how much bigger or smaller one quantity is than another in terms of percentages, that's what I mean when I say a percent comparison. So I'm going to do a couple examples for you, and then give you a little bit of instructions about the video, and then that's your task for the rest of the day. So you're going to need two numbers, and those two numbers could come from any two things that you could measure or quantify around you. The first two things that came to my mind super easily were these two weights that I have like sitting right beside where I'm always recording these videos from, because they literally have their weights like on the weights themselves. So like here, I've got a 10-pound weight, and here I've got an 8-pound weight. And so let's make a percent comparison about their weights. So if I was making my Flipgrid video, you guys should remember how those work. We've done them a couple of times in class. You'll be recording to the screen, and usually you use these little mini whiteboards that I keep in the classroom. I doubt you have one of these at home like I do, or something like this. So just use paper, I guess. Just make sure you're writing big enough and bold enough that you could see it on the screen. Or if you think you're pretty good at like writing on the screen, I suppose you could try using that feature in Flipgrid, but I personally never think that turns out good. You guys will figure it out. So anyway, so I got what, a 10-pound weight and an 8-pound weight, right? Okay, so 10 pounds, I'll write in blue, and 8 pounds. And I'm gonna calculate how much heavier the 10-pound weight is than the 8-pound weight in terms of percent. And that's really relatively easy. So there's a couple different ways to do this. If you know a different strategy than what I'm about to show, that's fine. That's just the way I've decided to do it. I'm gonna put the part over the whole to get a percent, right? That's one of the, I'm talking about this part right here where I wrote part over whole. That's one of the strategies that I've talked about in the videos. You know what I'm gonna do actually is, since the part in this case is actually the bigger number, the 10, and the whole is the smaller number, which is the red number, I know that I'm gonna get a percent over 100%, but just so it's easier to match them up, I'm gonna rewrite the word whole in red so that they kind of like go together. Okay, so my part is the 10 and my whole is the 8. So this is gonna equal 10 over 8. And when you simplify that, you get 5 over 4. So that's what I got so far, right? I put my part over my whole. It was the 10-pound over the 8-pound, and then I just simplified that to 5 over 4. But it's generally easier to convert a decimal to a percent rather than a fraction. So 5/4, I know, well, if I have 4/4, that's like the whole, and so 5/4 gets me like 1 extra, so it's 1 1/4. But as a decimal, it's 1.25, right? Kind of ran out of room there at the end, so it's kind of ugly, but and I just made it worse. 1.25. All right, well, 1.25 is the same as 125%, right? So I wrote that right down there. But that's not my answer, right? So what that means is that the 10-pound weight is 125% of the weight of the 8-pound weight. But it doesn't mean it's 125% more, or 125% heavier. That would be like if I had a weight that was double the 8-pound weight and an additional 25%, right? When you say something is 100% heavier, you're saying it's like having a whole extra thing, or in other words, it's double. So this isn't quite yet the answer I want. What I have to do is I have to take away 100% of this, right? That way I only have the extra amount, the amount by which the 10-pound weight is heavier than the 8-pound weight. So I'm going to subtract 100% from this, and I get 25%. So my answer in this case would be the 10-pound weight is 25% heavier. They're 25% heavier than the 8-pound weight. And I didn't necessarily have to do the heavier one. I could have done it the other way. I could have written a percent that says how much lighter the smaller weight is than the heavier one, which would be 20%, by the way. It wouldn't be 25%. It's never the same going up or down. So that's just one idea. Another idea I had was, like, maybe you don't have things that have their weights listed on them like I do, and maybe you don't have a scale at home so you could like weigh a couple things if you wanted to, but if you do, that'd be a good idea. Okay, well, maybe you could measure the length or the width of some things. So another couple things I had near me was Zelda Breath of the Wild, best game ever made. Final Fantasy Remake, second best game ever made. Let's see how the width of the cases that these games come in compare to each other. So let me measure the width of the Zelda case. It is, I'm going to make the numbers like easy on myself just because I can do that. So I'm going to call this 10 centimeters. Close enough. It's more like 9.8, but whatever. All right, so Zelda. Oh, I should put Zelda in red because it has red. And I'll put the FF7 in blue. So Zelda is 10 centimeters wide, and the Final Fantasy VII case is we'll call it 13.5. Final Fantasy VII case, 13.5 centimeters. You could use inches if you want to, or feet if you're measuring something bigger, or miles if you're gonna do something with Google Maps or something. You can be creative. All right, so I want to know, let's say, how much more narrow or how much like less wide, kind of a weird way of saying it, is the Zelda case compared to the FF7 case. So let's see here. I'll use a different strategy than the one in the example I just did. So in this case, instead, what I'm going to do is I'm going to find the difference between the two widths. So that's going to require a subtraction. I'm going to go the 13.5 for the FF7 minus the 10 for the Zelda equals 3.5. Right? That's the difference just in regular numbers, 3.5 centimeters less wide. Now, if I can represent that 3.5 as a percent of the Final Fantasy VII case, then I can say that the Zelda case is that percent off of the FF7 case, right? Like if this 3.5 is, I don't know, I'm just going to guess it's probably about 30% of this 13.5 out of the FF7 case, and that means that the Zelda case is 30% more narrow or 30% less wide. It's kind of weird the way you say it. So let's do that. So what I need to do is 3.5 divided by 13.5. 3.5 divided by 13.5. When you're doing this in your video, you can use any strategy you like. If you like setting up the algebraic equations and putting a variable in there for the unknown quantity, that's great. I would love it if you do it that way. It's kind of my favorite way, actually. If you can kind of do it in your head and sort of just like explain how you're doing it in your head, that's cool. If you like to use number lines or diagrams, that's cool too. Just show all that stuff. All right, so I'm doing 3.5 divided by 13.5 on the old handy dandy here. And I get 20.25925259. Okay, so it's 259 repeating. Okay, so that means it's 25.9 blah, 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 percent. I'm just gonna make my life easier and call it 26%, because my measurements weren't that accurate in the first place anyway, so whatever. So we'll round this to 0.26, right? Which I just wrote there in red, and that's equal to 26%. And so my conclusion on this one would be that the Zelda case is 26% less wide or more narrow, whichever way you prefer to say that, than the Final Fantasy VII case. All right, those are just a couple of ideas of what you could use for this activity. Some other activities would be like maybe play a game with your sibling or with a parent. And like if it's a game that has like a score or points involved. And then at the end, make a percent comparison between your score versus your mom or your dad's score or whatever. Like, oh, I scored 40% more in this video game or in this card game or this board game or whatever than my dad or my brother. Maybe challenge a parent to go outside. If you have a basketball hoop like in front of your house or whatever, like shoot a bunch of shots and keep track of who makes how many. And then at the end, calculate, oh, my dad made 10% more shots than I did, or I made 20% more shots than my brother. Or you could race someone and like time each other, like time how long it takes you to finish the race and time how long it takes them to finish the race, and then do a percent comparison between those two times. I ran the race 13% faster than my brother, or whatever. You could be super creative. Go to Google Maps and look at the distance between two places in the world that you're interested in and two other places, and then say, oh, this distance is 80% longer than that distance, or whatever. You could be super, you have a lot of freedom and creativity allowed on what two numbers you pick to use. And I have a challenge if you're up for it. So in your history class, you should have made this thing recently, or maybe you're going to make it later this week, I'm not sure. But it's a Mayan calendar. And when I saw this, it made me think of some math. So here's the challenge. I'm going to color in the innermost circle as red. I mean, I'm not going to do a really good job of coloring it, but there's now the inner part's red. And the outermost ring, I'm going to color as blue. And my challenge would be, can you tell me by what percent bigger the blue area is than the red area? So you'd have to calculate the area of the blue area, the area of the red area, and then make a comparison between those two. And you can do it the other way too if you wanted to, like how much, by what percent smaller is the red than the blue, either way. But the challenge requires you to be able to calculate both those areas and then make a percent comparison between those two. All right, so then you go to Flipgrid. I almost said vocabulary. Go to Flipgrid. The link is on today's activity announcement. You should be able to get in by just clicking the link and logging in with Google. You're going to need Flash on your computer. I assume pretty much everybody has Flash on their computer. You have to allow it to use Flash, just like when you get into ST Math. You might have to download it or something. You might have to allow it in your settings, just like you had to the very first time you did ST Math. And then when you're making your video, just try to be clear, show your work. If you're super shy and you don't want to be in the video like I am right now, you could always do this thing. You could like sit off to the side and show your work, and just like talk, but not really be like this or cover your face like this. You want. And then make sure to finalize your video correctly. Like when you're making your video, you click next, and it asks you to review it. And then you click next again, and you have to take a selfie that acts as like the picture people see when they look at your video. And you can be silly on that if you want. You can be kind of silly throughout the whole thing if you want. Like I know a lot of you like to have fun making the videos. As long as everything in it is school appropriate and the math is in there at some point, you can have fun with it. And when you get to the screen where it asks you to make a title and give it a display name, your display name needs to be your actual name, like first and last. The title can be whatever you want, just as long as it's school appropriate, I suppose. All right, have fun.